Hi, my name is Bill Wasserberger, Director of Research and Development for Brunswick Bowling Consumer Products. In this video, we will be looking at the USBC's proposed CG distance rule and its effect on ball reaction. The proposed USBC rule changes appear to contain assumptions and assertions that run counter to the concepts the Brunswick R&D team has taught in our Pro Shop seminars since 1991. It is Brunswick's hope that these videos will improve the fact base from which an informed decision can be made regarding the proposed rule changes. The proposed USBC CG distance rule would require all balls drilled after January 1, 2006 to have the CG within 1 inch of the bowler's grip center. After January 1, 2008, all balls used in USBC competition would have to have the CGs 1 inch from grip center. Non-compliant balls would have to be plugged and re-drilled or discarded. To help illustrate this rule, we start with a drilled bowling ball. The grip center is found by drawing a line in between the fingers and bisecting the thumb. The two spans are averaged and a point halfway between the thumb and the fingers is marked. This is the grip center. The proposed rule would require the CG to be within 1 inch of the grip center. The pictured ball would be illegal because the CG is 2 inches from grip center, even though this ball complies with the USBC static weight requirements. This illustrates one of the potential conflicts between the CG distance rule and the static weight rules, which the USBC has said they intend on keeping in place. A ball can pass the static weight rules but fail the 1 inch CG distance rule. Since 1991, the Brunswick R&D group has taught that CG position changes with constant pin position have little or no effect on ball reaction. We've tested this many times over the years using Throwbot, Pro Staff, and top amateur bowlers. In each case, the bowlers and observers involved are shocked at the minimal differences in ball reaction between balls with large differences in CG position. Let's use Throwbot to illustrate what we're talking about. We will be looking at an 8-shot sequence using 2 Power Coil 18 reactive cover stock test balls with identical core and pin positions. The ball on the left is drilled with the CG on the left side of the ball and has 5/8 of an ounce of negative side weight. The ball on the right is drilled with the CG on the right side of the ball and has 2 1/8 ounces of positive side weight. See if you can pick out which ball has the positive side weight and which ball has the negative side weight. We'll identify the throws later. Not a lot of difference. Throwbot breaks the lane down very quickly because it's consistent impact area and ball track. When the ball tracks for the 4 positive side weight shots are averaged together and plotted, and the ball tracks for the 4 negative side weight shots are averaged together and plotted, you get a graph that looks like this. There are actually 2 plots on this graph that are just on top of each other. The order in which the balls were thrown was positive side weight, negative side weight, negative side weight, positive side weight, negative side weight, positive side weight, positive side weight, and finally negative side weight. The reason there is little or no difference in the ball reaction between the positive and negative side-weighted balls is because the change in CG position produces no significant change in track flare. As you can see, the position of the narrow point and the separation between the tracks is very similar for the ball with 5/8 of an ounce negative side weight and the ball with 2 1/8 ounces of positive side weight. Many would say, that's impossible. After all, isn't the core way off to the right on the positive side-weighted ball and off to the left on the negative side-weighted ball? Not really. It's a common misconception that the core shift necessary to create large pin outs places the inner core well off center in the ball. Let's look at an animation to help illustrate what we're talking about. This animation was generated by Ray Edwards using the same CAD system Brunswick uses to mass model our bowling balls in the design process, so everything is exactly to scale. We start with a drilled ball, pin above the fingers, with the CG close to the bowler's grip center. We turn the cover stock translucent to reveal the position of the inner core. Now we do something that can only be done on the computer. We rotate the inner core about the pin. This shows how the core position would change if the ball was drilled with the CG out by the bowler's axis compared to having the CG closer to the grip center. Notice the amount of core movement. Not much. In fact, it's about 1/8 of an inch. Given the small change in the position of the core, it's not surprising that when the ball is put into rotation with the core in this position, then put into rotation in this position, there is no significant change to track flare or ball reaction. The example shown used a symmetric core ball. Brunswick's research has shown that asymmetric core balls perform in a similar manner. Two examples of the same asymmetric core ball with identical pin and PSA locator positions but different CG positions will have similar reactions on the lane. Brunswick believes that this example shows that there is little or no change to ball reaction, hook potential, and angularity when the CG is placed on different parts of the ball, and that the proposed 1-inch CG distance rule will result in no significant change to the scoring environment and therefore have no effect on any objective measurement of credibility or integrity. The 1-inch CG rule would force bowlers to plug and re-drill or discard thousands of bowling balls for no credible reason. Brunswick stands as the bowler's advocate. Brunswick urges the USBC to refrain from placing unnecessary burdens and ineffective regulations on the bowling public. Thank you for taking the time to listen to this Brunswick